let's look over here at 6.6 because there's a point to all this. And we have certain type of equations called quadratic equations, which are essentially just polynomials, or specifically the trinomials. In other words, they have an x squared inside of that equation. And when you have an x squared, you have to take this factoring root in order to solve them. Because with an x squared, it just works a little bit different than when you're dealing with just plain x's. Now, you have x's also, but the first thing that we look at here, we're kind of working ourselves backwards. This is the most simple case that where we're already set up. And you notice that it says x minus 8 times 2x plus 7. Notice that that's two binomials multiplying times one another. There's a property let's see. Yeah, here it is. It's called the zero property. I've heard it called the zero property of equality, but essentially what it means is that if we have two things that are multiplying one another, what that means is one or the other have to be zero, because if two things multiply out to be zero, one of them's got to be zero if they're set equal to zero. And you'll notice that that's what we have here. We have x minus 8 times 2x plus 7 is equal to 0. So what can we do in that case? Well, we just take each one of these individual binomials and set them equal to 0. So we take the x minus 8, set it equal to 0, and we take the 2x plus 7 and set it equal to 0, and we put an or in between, because it can be either one of those or both. So this one's pretty easy because we're just going to plus 8 to both sides, and we get x is equal to 8. Now over here, 2x plus 7 is equal to 0, so subtract 7 and then divide by 2, and we've got x is equal to negative 7/2. So that's how we find our solutions. And then it's really important to check them if you can, especially when you're doing your homework. I know that when you have tests and you're rushing, you don't always have time, but it's really important to build enough confidence, because you can see what happens, especially when it's in this form here where you got one binomial times the other. You're going to put 8 in for x, and right here what it does is 8 minus 8 is 0. Over here it ends up being 2 times 8 is 16 plus 7 times 23. But 0 times anything is 0, so this one checks. Now this one's a little bit more messy because it's a fraction, but the same thing happens. The negative 7/2 makes the right binomial 0, and so 0 times anything is 0. So what I'd like you to do is look at these first three here. Well, especially to get the first one. I'll just explain also that if we had a third term multiplying, you just set all three of them equal to 0 and solve. This one is going to, and this one are going to be kind of a trivial solution, because you essentially got your answer when it's set equal to 0, but you set all three of those individually to 0 with the or in between. So try number 1 and let me know what you come out with. All right. So let's see. Good job, Christiana. Anybody else come up with one? So notice that when you do that, these things are generally real easy to solve. So you get a +1 here, +1. So x is equal to 1, or all right, any questions? And you can kind of see, just spot check it. If you put the 1 back in there, 1 minus 1 is 0. 0 times this, even when you put the 1 in there and it becomes 8, it's still going to be 0. So that's good. And the same thing over here. It just happens on the one to the right. -7 plus 7 is 0. Times -8 is going to give you 0 also. All right, so try number 2. Like I said, on that, you're going to have 3 solutions, although one of them is going to be not much to do to it. Yeah, it looks good, but keep on going. See if we can get a couple other people woken up here. I'm having trouble squeezing these in here, it looks like. All right, so this one right here, when you got just, it doesn't matter how many x's you got, but if it's set equal to 0, it's going to be 0 because when you divide here, anything divided by 0 divided by anything is 0. This is a +3. All right, and again, if you put 0 in here where this x is, that's going to put 2 times 0 is 0. And then this would be -3 times 0, which is 0. And then this would be -2 times 0, which is 0. And then same thing here. It only really matters what happens in the one where you got the solution from, because that's going to give you 3 minus 3 is equal to 0. And 0 times these other things is 0. Same thing happens on this one. 2 minus 2 is 0. And then 0 times any of those other things is fine. All right, try the third one. We probably need a little extra room there. So set all three equals 0. Well, let's see. Or I guess what I'm going to do is just come down here. Well, x equal to 0 is pretty obvious, all right? A 2x minus 3 Well, I got enough room to do it here. All right, so what's the answers on these? So you got 0, which is obviously going to zero everything out and make it true. -5 makes this one 0, and 0 times these other two, no matter what, it's going to be 0. And then over here, x is equal to 3/2. Now that one right here is what's going to be affected. So let's kind of put it in there. Like I said, you don't always have the time to check, but I just like to stress that if you're able to check, especially when you're doing your homework, it really builds up your confidence because you know how often you make a mistake. Now just remember, this is 3/2, and this is 2/1. So what's left? It's 3 minus 3 is equal to 0. And if that middle term is 0, even if this is -3, I'm sorry, even if this is 3/2, and then this is 3/2 plus 5, which is 6.5, then you just multiply by 0 and you got all of them. All right, any questions on those? All right, let's go on. All right. Now remember, we've been looking at them for the most part. We've been looking at trinomials in here. We did show that when you multiply, that trinomials can be factored as two binomials. And the reason why is so we can solve these trinomial equations, which are called quadratic equations. All right. Now, we talked about this form. Well, this is what we call the form, the basic form for a quadratic. notice, and then these don't have any A in front of it, so technically what you're looking at is this one. We'll have something like this in a second, in a few minutes, but the main thing you're doing is you've got on the left-hand side, you've got the trinomials in descending order of their exponents. Okay, descending order. So it really needs to be like that. All three terms on the left-hand side and z equal to 0. So you'll notice that this one here is not equal to 0. It's x squared minus 5x is equal to 24. So what we got to do is we got to subtract the 24 from each side. That's what they say, rewrite the equation in standard form. So in order to get rid of it here, positive 24, we subtract 24. So then that's what we end up with right here. All right. Now we got to see if we can factor it. For the most part, they should all be factorable. You might run into one that's not factorable, but the reason why we're doing these is we're learning how to factor these quadratics. All right, so numbers that multiply out to be 24, and since this is negative, we're looking for a difference of 5. So 8 and 3, we also have 6 and 4, but that's not it. 6 and 4, difference is 2. 12 and 1, I'm sorry, 12 and 2 has a difference of 10, and 24 and 1 has a difference of 23. So there's always only one pair that works. So x minus 8 times x plus 3 is equal to 0. So set x minus 8 is equal to 0, or x plus 3 is equal to 0, and then add 8. So x is equal to 8, or x is equal to negative 3. And then look at the check. Like I said, especially if they're whole numbers, it's real easy to check. But you put in 8 for x, so 8 squared is 64. Negative 5 times 8 is negative 40. 64 minus 40 is 24. So that's a good solution. Same thing over here. Negative 3 squared is 9. Negative 5 times negative 3 is 15. 9 plus 15 is 24 is equal to 24. All right, any questions about those? All right. See, this is missing the third term. Nothing wrong with that, because as long as we've got an x squared term, That's what determines whether we can use factoring. So all we're going to do is just take out that GCF on this one. There's no trinomial to factor. All right, so what does this mean? Well, this one, once you set it equal to 0, you pretty much got your answer. And you can see that it works because 0 squared is 0, and then 15 times 0 is 0, 0 minus 0 is 0. So on this one, all right. And you can kind of see fairly easy that the 15 works because 15 squared is the same as 15 times 15, and there's a negative in between there. So that's I think that's 225. What is that? 15 times 15, I think it's 225. Yeah, so that ends up being 225 minus 225. So we got another solution. All right, so give 6 a whirl. All right, remember, you got to have everything on the left-hand side. So minus 15x plus 50. Yeah, okay, so this is positive. We look for the factors of 50 that add up to be 15. So 10 times 5, and they're both negative. So x is equal to 10, x is equal to 5. Good. So 100 plus 50, it's 150. And then if you put 10 over here, 15 times 10 is also 150. So 150 is equal to 150. So 5 squared is 25. 25 plus 50 is 75. 5 times 15 is also 75. So, those all both work. All right. So 7 will probably take a little bit of time. 8, I just probably should emphasize when we started this section here with number 4. If you can find the greatest common factor, take it out first. And sometimes what that'll do is it'll make things simpler to do the factoring then. But going to number 7. There's no greatest common factor between 30 and 11. So you just got to kind of use a long way there. We may have to write this on the other board when we start because there's needs some room. All right. Good job, Elsa. Looks like you did that quick. All right. So you got to have it in this form. It's got to have everything, all 3 terms, simplified. And on the left-hand side, set equal to 0. Well, technically, you could have them all on the right-hand side, set equal to 0, either one. So 30 times 30 is 900. because we need numbers that multiply out to be 900. And they have to have a difference of 11. And just remember, if you don't get it, you can just keep on going down and get the ones you need. See, this is 5 times 5. Once you get to a prime number, you're done. And then these are going to keep on going to 2 and 3. And once they're prime, they're fair game. Now, you can do these in any order you want. And as I said, I had 25 as one of them, because the difference has to be 11, and that's 11. So, and all these actually multiply out to be 36. But you can always take them in any order and find the appropriate ones if you can't find it right away. So take out the greatest common factor, which is 6x plus 5. Bring down that sign, and you can take 6 out. And then you got 6x plus 5 again, the repeated one. So once we got them set like set as two factors or represented as two factors, we can just set each one separately. Yeah, good job. That was quick. That's all. All right. All right. Any questions about that? I'd already worked this one over there, but anyway, see, and then when I did it before, like I said, you do it a little bit differently. You can still move the factors around to do whatever you find the ones that give you what you want. You got to have that middle number. All right, let's go back here. So this was all right. So go ahead on to this one, and I'll just give you a little hint. I'll tell you what. So that's number 8. And like I said, I put it over here just to give us a little bit more room. So give that one a try. Let me know what you come up with. And I'll just reiterate, if you can take out a greatest common factor, take it out immediately, and it'll make things easier. And you'll hopefully see that 8 that has a common factor of all of those. You still kind of have to use the long method here, or do your trial and error, but it's going to be a lot easier once you take out the greatest common factor. And if you don't have to take the greatest common factor out, well, it'll probably still work. It's just that if you're asked to factor something like that, with all the factors, then you've got to take out that one, that GCF. For the solution, it's not that important, but for factoring. All right, so all right, so yeah, let's see what happens. So like I said, I'm going to take out the GCF. Well, first of all, I'm going to rewrite it with the 40. Or minus and 40. So the GCF is 2. Now, if we were asked for all the factors of this quadratic, then we'd keep that 2, bringing it along. But since it has no x in it, it really doesn't provide a solution. Only time it would provide a solution is like if it were 2x. But anyway, let's see. So 3 times that, so it's negative 60. it's 60, and the numbers have to have a difference of 11. So what are those? 30 and 2. So that's not it, because that's the difference of 28. 60 and 1 is not going to do it, because that's a difference of 59. Let's say 15 and 4 seems to be the pair. Okay, 15 minus 4 is 11. Okay. And the 15 has to be negative because that's larger. And then I'm going to use my factoring by grouping. So on this side, take out a 3y. And then that's going to give us, well, you know what? So 3y is the GCF there, and then that's going to be y minus 5. Bring down that sign, so that's plus 4, because 4 goes into 20. And then that's y minus 5. So all right, so as I said, is the 2 is technically a factor. So if we were asked to factor this, like in previous sections of this chapter, then the 2 would come along with it. But it doesn't provide a solution because it doesn't have a variable in it. So here's our only 2 solutions. Y is equal to 5. And 3y is equal to 4. And it's negative, because once you subtract that over that. All right, any questions about that one? All right, now with this one, we should have enough room over here. All right, now this is totally different than one like this, or even like this, because these were already set equal to 0. This is not set equal to 0. So you have to just simplify this, collect your like terms, whatever else you need to do, then set it equal to 0. It does not work with 2 factors set equal to 14, because there's no property that deals with that. The 0 property of equality means that if 2 factors are equal to 0, then one or the other or both going to be. Well, that's fine. I mean, one thing I don't push is, you got to do it like me and all that, even if it was, regular face-to-face course. I mean, I've always tried to encourage students to kind of use the tools that they have, the things that make sense to you. As long as you're um, following basic rules that we've learned, there's always going to be more than one way to do things for the most part. It's just like building a birdhouse. You give everybody a piece of wood, the same size piece of wood, and the tools. Everybody's birdhouse is going to effectively look a little bit different. Now, it still has the same property that it houses birds, but how you get to that point is up to you. Now, there's certain things you gotta take into consideration. You gotta cut your wood right. You gotta nail your wood right. So those are things that are part of your toolbox that you make part of your toolbox. All right, so what happens with number 9? I mean, and as I had said about number 8, you can go ahead and just move the 40 over and then factor that, and you should come out with the exact same answers. You don't have to take out the GCF. You just have to watch out that if that were just a trinomial and it said factor completely, then you need to take out that 2 because 2 is one of the factors. All right. So what we got to do is just multiply through. So that's 3x squared. X times -1 is -x is equal to 14. Now we minus our 14 to both sides. You can't do that before well, you can, but you just don't want to make sure you don't multiply times the 14, -14. But anyway, then you got 3x squared minus x minus 14 is equal to 0. All right. Now we got to find out the fact that, the numbers here. And like I said, is however you do that, I'll leave that up to you. I'm going to go through the method that I've shown you just because I like it. There's other ways to do it. So we got to, so 3 times 14 is equal to 42. All right, 42. So factors of 42 that have a difference of 1, well, there's really only three factors. There's 6 and 7, and 6 breaks down to 2 times 3. But you don't really need to do that because 14 times 3 does not have the difference of 1. So you need the 6 and the 7. And we need to have the larger one negative because that's negative. Well, so we'll make the 6x positive. And then here's the negative 7x minus 14. And I don't know if you see in the strategy that I'm doing, it really does not matter because we could have put the negative 7x first and then the 6x second. And I thought I had showed you that last week, that it doesn't matter how you line those numbers up. It's going to switch the repeating factor. I just do this because I know that 3 and 6 have the same factor. So 3x All right, so x we'll have to go over somewhere else and finish this. So I'll just come up here. So x plus 2 is equal to 0 means x is equal to negative 2. And then 2x minus 7. So that's 2x is equal to 7. Oh, that's a 3 in it. I'm sorry. I got those. I don't know if you noticed, but you can click if you want a transcription. So the captions are going on at the bottom, but it covers up things. All right. Any questions? All right. So let's just go ahead and check this one. Like I said, I just want to make sure you understand that process. Okay. So we had x is equal to negative 2. All right, so what was the original? It was x times 3x minus 1. All right, so let's just check in the original. So negative 2 times 3 times negative 2 minus 1. Is that equal to 14? We'll see. All right, so this is negative 6 minus 1. And it looks like that's going to work because that's a negative 7. So we know that one's good. All right, fractions are a little bit harder to check, but usually if you just remember to line up numerator and denominator, you're going to lose your fractions for the most part. Remember, that's 3 over 1. Let's see. So that's going to be 7. Hold on a second. 3 over 1, 7/3. Those is going away. That's 1. Oh, okay. I see what's going on. And that's 6 over 1. 3 goes into there twice. 2 times 7, 14. All right, so that one works too. All right. So those were your 2 solutions, okay? So any questions about any of this? All right, well, why don't we take a little bit of break? We only got one more section. It's really not so bad. It's the problem solving. So the skills that we use for problem solving, like back in, I'll bring this up. All right, so let's get back on the road with the show here. Or like I said, we're going to be able to finish up this chapter today, and then Wednesday we'll be reviewing. All right, and then wait a minute, that's Tuesday and Thursday. So finish up today, and then the test. Well, I'll tell you what. Let me just look at it and see what if it's all set up and everything. They do open a little bit early, but sometimes, but she puts a password on them. All right, so that test it'll open up. It was already out there, but she puts a password on it. So I just set it without the password to open up at midnight, tomorrow, and then that way it'll be open up until Thursday. Okay. All right, so let me do one more thing when I'm thinking about it, because I got that Tuesday and Thursday class that it really needs to be a day ahead, and I thinking now I would have set that before I forget. No, there's a few people that want to take it early always, but there's always usually most people want to wait until last minute, but I hate to have people that want to take it early and then not being able to. So All right, so just trying to refresh your memory about how those problem solving works. You got things decreased means to subtract, increase means add, sum means add, difference means subtract. Um, the product means multiply, and of course is, or is it equal to. All right, so that's what we did over there, and we've used it a little bit in most chapters because every chapter's got its own little set of applications or word problems, if you will. All right, and then I wanted to emphasize this because I was just looking at some of the grades. Please take advantage of those practice tests. I mean, that's half the battle, is if you can do practice on those tests, you get a general idea of what you're going to come out with. If you just go into a test cold, and I noticed that people have done that on all the tests, not everybody on every one, but you don't know how prepared you are if you just go in and take a test. I mean, a test is not like this right that's automatically going to translate into a passing grade. Sure, you have a right to take the test, but if you're not prepared for it, what do you think is going to happen with the grade? So use those practice vehicles, or any kind of a review or anything like that helps you. Believe me, I mean, most of the time I can predict how people are going to do on tests by looking at the practice score test. All right, so let's go on over here. And look at this word problems. All right. Now, sometimes it's helpful to know a formula of some sort. And for that first one, that's certainly no different. It's not a fancy formula, but I'll write here. Area is equal to length times width. In other words, if you've got a rectangular room and you want to put a rug in it, well, you got to know the area because that's how carpet is sold, with areas. So you're going to buy a certain area carpet, so you multiply out the length of the room times the width, and that's what you would get. In other words, it says here the area of a rectangular rug is 75 feet. So when you go to Home Depot or Lowe's or wherever that sells carpet, you tell them you want 75 square feet of carpeting. Now, they also have to kind of match it up with length times width, because you also want to minimize the number of places where you're having to patch. In other words, you hopefully like you would have to kind of do two pieces if your width was longer than whatever the carpet was sold as. But for the most part, that's how you do it. Area is linked to times width. Now let's write these down. They tell us that the area of a rectangular rug is 75. All right, and then again, here's going to be our problem solving kind of thing that we looked at in that little one that I just showed you from back in the olden days from chapter 2. All right, and it tells us the measurement of the length is 3 times the width. 3 times the width, 3W. So the length is 3 times what the width is. So in other words, if the width is 5, then the length would be 15. If the width were 10, then the length is going to be 30. It's just 3 times whatever you're dealing with. All right, so now we've got these 2 bits of information. And you know what? If we substitute into this, I'm just going to write this here. And I'm going to put 75 there. I just don't have to start over. I don't know how to get that thing to. So A is equal to length times width. So we're going to come down here and we're going to put 25 for A. And then we're going to replace L with 3W. And there's already a W there, so we'll just put the parentheses to show that it's multiplying. All right. So now we got on this equation. Let's just go ahead and simplify it. All right, and then you can write it this way if you want. Like I said, I like to have it in the descending order. But if you subtract 25 from both sides and then turn it around, that's what it looks like. All right. Now, we're going to solve this. Now, here's where you can, hold on a second. Hold on a second. I don't know how to solve this. I don't know why my brain is going haywire. Did I not write something right? Hold on a second. I must actually done it on there, so let's see. All right, so 3. Oh, I'm sorry, it's 75. What am I thinking? 75. Yeah. Because I wanted to take out a common factor first. to get rid of that 3. And so this is a 75. 7.5. All right. So the way to proceed here is to factor this, but in order to factor it, you take out the GCF, so it's 3 times W squared minus 25 is equal to 0. Again, since there's no variable in the 3, then that's not going to lead to a solution. So what we're going to do is we're just going to factor this part as W minus 5. So that means W minus 5 is equal to 0. Or so this is going to be W is equal to 5. Or, all right. So we got 2 solutions. Now, here's the thing you got to watch out when you're dealing with applications. When we're talking about things like lengths, widths, time, there are no negative values. So we have to kind of weed out any non-viable solutions. So there's no way for the width of a rug to be -5. So the width is and you know this is right because if you put 5 in here, 3 times 5 is 15. They don't ask for this, but I'm just doing it as kind of a check. And then you can see if you take 15 times 5, length times width, is 75. And that's what you got. So this is what they wanted to know. Width is equal to 5 feet. Now, some of the other ones are going to ask for all of the possible sides, like for this one. And let's see, this is the one I actually had over here. And it really needs more room. Was that the one? All right, I'm going to come over and show you that one. That's number 3. All right. Now, one of the things you got to remember about right triangles, and a right triangle is just one. Let's see if I can draw. Right triangle is like this. All right. Try that again. So what this is called, or what we use to do this, is called the Pythagorean theorem. To just refresh your memory, most people have seen this, but this is what the Pythagorean theorem does. It's if we have a right triangle, which is pretty much just like what I wrote there or drew out there, then that we know that the relationships of the side is the small side, a squared, plus the next side, b squared, is equal to the hypotenuse, usually called c squared. So sometimes it's called h, but we'll just do with it. H is the hypotenuse, but all right. So it says one leg of a right triangle is 7 inches. All right. So we'll just say this is 7. And it says the hypotenuse is 1 inch more than the other leg. In other words, C is equal to, hold on a second. What am I like? Did I mess something up again? What are you? My triangle is 7 inches. The hypotenuse is 1 inch more than the other leg. So this is the other leg. So they tell us one leg is 7 inches. So this is B plus 1. Because we want to take out and only have one variable. So now we're just going to use a squared plus b squared is equal to c squared. And we know that a is 7. We don't know what b is, so we're just going to leave it like that. But they tell us that the hypotenuse is 1 inch more squared. So when we do that, we got to square that binomial. All right. And so I'm just going to use the formula on that. That's b squared. 1 times b is b times 2, so that's 2b. And 1 squared is 1. All right, so that's how this looks. And then we're going to subtract b squared. And you know what? I don't know if someone did look at this or is there a reason why they wanted this one, but this is going to be an easy one because there's no factoring involved. Because we're losing our b squared. So we got 2b and minus 48, I'm sorry, because it's positive 1. And then this is all 0, so I'm just turning it around. So that's 2b is equal to 48. Add 48 to both sides. And then divide by 2. So this is 7. This is equal to 24. It's not really proportional, and then this one is equal to 24 plus 1, which is 25. but you don't really know kind of what that is, what it's going to look like until you get the size if you needed to draw it. But the point is not to draw it. All right. So let's set this one up, and I'm going to go over there and show you. And then I'm going to task y'all on 4 and 5. All right. The longer side of a right triangle. So that's B. That's considered the longer side. And then we're going to just say that it's A. So in other words, we're doing the same thing. I'm going to just do it real quick. So this is A, B, and C. So B is equal to the shorter leg plus 3. C is 6 more than the shorter side. All right, now this was where this one kind of gets messy, but I can't promise you're not going to see these because. All right, so what we got to do is we got to put this all right, we got to put all these in there. So we know what B is and we know what C is. We just don't know what A is. So A squared is going to stay there. This is A plus 3. So what happens on this? Like I said, it's a bit of a mess, but this right here is a good place. If you haven't figured out where to use the formula at, you can use it to make those quick, because A times 3 is 3A times 2. So 6A is going to be in the middle, and you got A squared plus 6A plus 9. Same thing with this one. 6 times A, so 6A times 2, so 12A. So let's go over and show it, because I've already done it over here. And I took my time on this one. All right. So there's the answers I filled in. But anyway, this is what I just showed you there. If you FOIL this out, or if you use the formula, you're going to get A squared plus 6A plus 9. You FOIL this out or use the formula, you got A squared plus 12A plus 36. All right, then we can collect like terms. A squared and X squared is 2A squared. You got 1A squared over here. When you try to simplify, subtract it, it takes away one of them, and you're just left with the A squared. All right, you're going to subtract the 12A from the positive 6A, and that gives you negative 6A. Subtract 36 from positive 9 gives you negative 27. Set that and set equal to 0, because that's all 0 now. And then that's factorable as A plus 3, A minus 9. So this one gives us A is equal to negative 3. We don't need that one. But A minus 9 is equal to 0 gives us 9. That because that's a positive value, because we need that for when we're dealing with a length or a width or something like that, any kind of a measurement. There are some times, if it was talking about just integers, then you can have positive and negative answers. But when we're dealing with these things that have lengths and widths, no negative outcome. So 9 is our key thing here. So that's why I put 9 there. We were told that A plus 3 is the long side. It's equal to B. So 9 plus 3 is equal to 12. That's what that is. And then the hypotenuse was 9 plus 6, which is 15. So there's our 3 sides, because they wanted all 3 sides. So the short side is 9, the longer side is 12, and the hypotenuse is 15. All right, I want to give y'all I want y'all to work on this one, and I'll just tell you, there's nothing really to do here except replace the h with a 0 because it wants to know how long it takes to hit the ground, and height of the ground is 0. So replace the h with 0, then try to solve this. I'll give you a few minutes. The one thing I would recommend on it is taking out any greatest common factor over here, because that'll make this a whole lot easier to solve if you do that. But whatever way you want to do it is great, as long as you can factor that and solve it. So I'll give you a couple of minutes. They use T because that means time, short for time. It doesn't matter which side the 0 goes on, but I'm putting it on the right-hand side because that's just kind of traditional. Let me ask you this question. What's the greatest common factor? What's the largest number that'll factor out of all of these three numbers? All right, the first thing I would just suggest trying is negative 16. So let's take 96. So that's a perfect factor. What about 112? All right, so 16 is a factor, but I would also recommend taking out the negative sign, because if you don't, this is going to be negative, and unless you're really good at factoring like that with that leading term being negative. Now, if we were factoring a quadratic, factoring a trinomial, and they wanted to see all the factors, then the negative 16 has to go along with it. But since there's no x in there, it does not yield a solution. So the only thing we have to worry about factoring is this one. What does that factor as? Should be an easy one, because you've got the third number is a 7. There's only two factors of 7, 1 and 7. So what's the factors? They both got to be the same sign, and they both have to be negative. Positive means they both have to be the same sign. This tells you what the sign is. Hold on a second. Did I do that? I think I messed up with my sign, that middle sign. Let's see. This is positive 6. I'm sorry. So both of these are positive. Hold on a second. I think I got it. I'm flipped the signs. 112 divided by 16. So this is where the negative is at. I apologize for that. So let me write that again. So you're going to watch that. It changes when you factor out the negative 16. So they got to be different signs, and the larger one's going to be positive. So t plus 7, t minus 1, t plus 7 is going to give us let's see. This is also darn negative. What am I talking about? So this is negative. Hold on a second. Let me write something down. Writing on that board is kind of cumbersome sometimes. All right. All right, let me just do that again, make sure. Okay. I should have just used the negative and instead of thinking that my brain could handle it. So positive 96 divided by 16 negative. Whoops. 96 divided by negative 16. So negative 16 is right. So this one is also negative. So both of these are negative. So that means the larger one is negative, right? Okay, and then this one's positive. So sorry about that. So this is t minus, so I'll come over here, and t plus 1. So t plus 1 gives us t is equal to negative 1. Since we're talking about time, then we don't want that one. So t minus 7 is equal to 0. So t is equal to 7. So that's the positive. So 7 seconds. Now just let me show you something real quick. And then I'm going to give you this one, and that one is your ticket out of class. When you finish that one's a lot easier. So let me just kind of show you this. let's see, it's negative. All right, so if we graph this, it's going to be hard to see it because all right. All right, I'll show you in a bit. Let's just finish because we're going to run out of time. I don't want y'all to be here too late. Try to work this one. All you need to do is take this 127. All I'm going to show you is and replace the C with it, then simplify it. What I was going to show you over there, and I'll show you on, if I can remember, on Wednesday, just to show you that both of those equations have the same solution. And that's why we can take out that greatest common factor. All right, so solve this. When you get it done, let me know, and that's your ticket out of the class. Because they tell us that cost is C, and so they want us to know the number of units for a cost of 127. All right, how are y'all doing? Gotta set it equal to 0. And I think that is 80, right? So find the factors of 80. Let's see. 20 and 4 looks like they'll do it. Difference of 16. The larger one has to be negative. All right, this is going to be the negative one, so we can throw this one out. So x is equal to 20. That's an equal sign. X is equal to negative 4. Again, you can't produce negative, so 20 units. All right, there you go. All right, so like I said, you got about 2 days here, so step up on it because there's not much time left in the semester. It's going to come quick.